Hello everyone, my name is Mulutra Enoch and we are going to revise together CH110 under Stoichiometry, and the question reads: ammonia reacts with fluorine to produce dinitrogen tetrafluoride and hydrogen fluoride. In an experiment, 4.0 grams of ammonia and 14.0 grams of fluorine are combined. So the first question they are saying, write the balanced chemical equation. So it means that ammonia reacted with what? Fluorine to produce those two products. So we start. So that is, they are saying ammonia reacted, so make sure you put state symbols. So reacted with the fluorine to produce dinitrogen tetrafluoride gas plus hydrogen fluoride, this gas. So balancing is just the process of making each number of atom equal to the both sides, that is the reactant and the product. So we are going to counter check the number of atoms. So there we are having 1 nitrogen, so to the product we are having 2 nitrogen. That simply tells us to say nitrogen as not what? Balanced. So I'm going to put a 2 there in front of ammonia, and then I counter check again. So 2 nitrogen, 2 nitrogen, so it means that nitrogen as what? Balanced. So from there we go to what? We go to hydrogen 3, hydrogen what? 1. So hydrogen, make sure you consider that number in front of ammonia. So it's 2 times what? 3, which is 6. So we are having 6 atoms of what? Hydrogen. So to balance, I should put a 6 there in front of hydrogen fluoride. So from there I go to what? Fluoride, that is 2 fluorine. There I'm having 6 plus 4, which is 10. So that simply means that I am supposed to put a 5 in front of fluorine. So if you try to counter check, you find to say that the equation as balanced. So this is our final answer. So we proceed to the next question. So the next question they are saying, which reactant is the limiting reactant? So one thing that you should bear in mind about the limiting reagent is that those are just what? Substances or reagents that are used up completely during what? Chemical reaction, and they are used to determine the what? The product of anything. So we can start answering. So looking at the question, we have been given the 4 grams of ammonia and 14.0 grams of fluorine. So we have been given 4.0 grams, and then we have also been given what? 14.0 grams of fluorine. So every time when you are finding the limiting reagent is that you convert all the masses, volume, to what? To the number of moles. So we all know that the number of moles is calculated by mass over what? Molar mass. So from there, since you are having mass, we have to find the molar mass for what? For ammonia, that is NH3. So we are having 3 atoms of what? Hydrogen should be multiplied with the what? The relative atomic mass, the number that is found on top of each element on the periodic table, which is 1.01. So when you multiply, you're going to get 3.03. So there, 1 atom of what? nitrogen multiplied by its what? Relative atomic mass, which is 14.01. So you are getting 14.01 there over. So when you add, you are going to obtain 17.04 grams per mole. So make sure that you put the what? SI unit, because the SI unit in chemistry and physics, they mean a lot. So you can find the number of what? Moles. So number of moles is equals to 4.0 grams of what? Ammonia divided by 17.04 grams per mole. So there you cancel. So number of moles is equals to, so when you divide, you are going to get 0.23 moles. So from there, what you are going to do is that you are going to divide the same number of moles that you have calculated by its mole ratio. So the mole ratio is the number that is found in front of each atom or each compound. So that is 0.23 moles divided by what? By the mole ratio, which is 2 moles. So there you cancel, and you are going to obtain 0.115. So you just keep that number. You also have to find the number of moles of what? Fluorine. So mass over molar mass. So number of moles is equals to the mass of fluorine, that is 14.0 grams, divided by its what? Molar mass. So fluorine is a diatomic what? Element or molecule. So you have to multiply 2 atoms of fluorine there, multiplied by what? The relative atomic mass, which is 19.0, and you're going to get 38 grams per mole. So we are going to put there under the molar mass 38 grams per mole. Then you cancel, you are going to obtain the number of moles to be 0.37 moles. So like I said, every time when you calculate the number of moles, divide by its what? Mole ratio. That is it, the number that is found in front of fluorine, which is 5. So you divide this 0.37 moles divided by 5 moles. You cancel, and then there you're going to obtain 0.074. So after finding these two values, what you are going to do is that you are going to compare these two values, and then the value that is smaller, you are going to consider it as a limiting what? Reagent. So if you compare 0.115 with 0.074, you are going to find to say that 0.07 is small. So you are going to conclude that therefore fluorine is a limiting reactant. So this is the final answer for B. So we proceed to the next one. So the third question, they are saying how many grams of dinitrogen tetrafluoride can theoretically be prepared from this experiment. So we can calculate. One thing that you should bear in mind is that the limiting reagent determines the mass that is produced. So what you are going to do is that you are going to get the what? The mole ratio. So 3 so that is 5 moles of fluorine, since it is a limiting reagent, with what? 1 mole. So the number of moles of fluorine is 0.37 moles. So 0.37 so 0.3 moles there, just put x, more goes there, that is 5x is equals to 0.37. Divide both sides by what? 5 by 5. So x is equals to what? So when you divide, you are going to get 0.074 moles of dinitrogen tetrafluoride. Now they are telling us to calculate what? The grams, which means the mass. So number of moles is equals to what? Mass over molar mass. So you have to find the molar mass for what? Dinitrogen tetrafluoride. So there, what you should bear in mind is that you are having that one, which is 4 atoms of fluorine multiplied by its what? Relative atomic mass, that is what? 19.0, and you are getting 76. So that is 2 atoms of nitrogen multiplied by its relative atomic mass 14.01 is equals to 28.02. When you add those two numbers, you are getting 104.02 grams per what? Per mole. So now you can calculate the mass by just substituting the number of moles, that is 0.074 moles is equals to what? Mass over what? The molar mass, which is 104.02 grams per mole. Then you cancel there, you cancel, so your mass is going to be, when you multiply those two numbers, there is just over 1, cross multiplication, you are going to obtain 7.70 grams as your final answer. So we proceed. So we go to 4, where they're saying if 4.8 grams of dinitrogen tetrafluoride are obtained from this experiment, what is the percentage yield? So one thing that you should bear in mind is that always the actual yield is given, and the one that we have calculated is called the theoretical yield. So we can start calculating. So percentage yield, that is just the ratio of what? Actual yield over what? Theoretical yield times 100%. So percentage yield is equals to the one that you have been given, which is 4.8 grams. That is the actual yield, and then the one that we have calculated, the theoretical yield. So you replace cross by, multiply by 100%. So if you simplify or tabulate everything on the calculator, you are going to obtain, so you are going to get 62.3% as your answer. So this is part 1 stoichiometry calculation. So if you want to see the solutions of B, you have to watch part 2 stoichiometry calculation. So see you in the next video. Don't forget to share, subscribe, and like the video. See you.